In this problem, we are looking to find the radius of the Large Hadron Collider when given its circumference and an equation for the circumference. They give us the equation that circumference is equal to 2 pi times the radius. So we have the Large Hadron Collider, which is a big underground loop that sends particles around at high speed. And we're given that c, the circumference, is equal to 27 kilometers. But what we're really looking for is the radius, r. And so given that equation, we can isolate r with a little algebra. R is going to be equal to c divided by 2 pi. And if I plug in my value for c, I get 27 kilometers divided by 2 pi. And I can use my calculator and plug that value in. I get 27 divided by 2 pi. Now if you look at my calculator here, I get a value of 42.4. However, that's not the correct answer. A common mistake when we divide by 2 pi and when we type it in our calculator is to forget the parentheses. If I type in the same thing and put parentheses around the 2 pi, then it'll evaluate 2 pi as one thing and I get a different value. That's the correct value, 4.297, and my units are kilometers. What's happening when you don't have the parentheses is your calculator will take 27 divided by 2, which is about 13.5, and then multiply it by 3.14, which gets you the 42. So be careful in your calculator of when you divide by two values that are being multiplied that you put the parentheses in there to make sure that they're grouped together. I could also type this in as 27 divided by 2 and then divided by pi again, and I should also get the 4.297. However, I'm not done in this problem because they ask for the radius in meters. I could have converted 27 kilometers to meters initially, or I can convert it at the end. And I'm just going to create a fence post. Now, most of us hopefully can understand that it's just a simple metric conversion where we can move a decimal, but really all we're doing when we move a decimal is we set up a fence post, and we want to end up in meters, and we want to get rid of kilometers. And I know that there are 1,000 meters in 1 kilometer. And using this fence post method, I can cancel kilometers, and I'm left with a unit of meters. And if I multiply by 1,000, I'm really just moving the decimal place 3 places. So I get 4,297 meters as my answer for this problem. Let's move on to the next one. This one's a little bit more challenging. This is a conversion problem where we're really converting from pounds per square inch, which PSI is the short term, but from a physics standpoint, if I was going to write it out as a unit, I would prefer to write it like this. That's a better visual way to look at how this unit of pound per square inches can be written. And so this is a great problem to use what I call the fence post method. And what we're really doing is we're taking our initial value, our 14.7 pounds, and I like to write it like this, pounds per square inch. That's a good way to write it to really see it in its fraction form with the 14.7 in the numerator. And what we want to get to is to have in the numerator newtons and the denominator meters squared. And we're given some conversion factors that we can use for our fence posts. And so really I'm going to go step by step to change the units that I want, that I have into what I want. And all I'm really doing is multiplying it by 1 over and over and over again. So for example, let's get from pounds to newtons. Well, I want pounds to go away, and I want to get to newtons. So by putting pounds in the denominator, I can cancel it algebraically. And I'm left with newtons, which is what I want in the numerator of my answer. However, in order to make this fraction equal to 1, I use my conversion. And 1 newton is equal to 0.225 pounds. So now that fraction is really, I just multiply by 1 which doesn't change the value or the amount, but it does change the unit that I'm in. So now when I were to multiply, if I were to take 14.7 and divide it by 0.225, I would end up with a new value, and the unit of that overall value would now be in newtons per inches squared. But I'm not done. I want to get from inches now to meters squared. So again, the fence post, sometimes you'll see it drawn out like this with just a bunch, and use however many I need. But it's really just multiplying by fractions equal to 1. So what I want to do now is get rid of inches and go to meters. Now, I don't have a direct conversion to meters. I do have a conversion to centimeters. So, and I can go from centimeters to meters. So I'm going to go from inches to centimeters right now. And I know that 1 inch is equal to 2.54 centimeters. However, in algebra, if I had x squared in the denominator and I multiplied by a single x, I would only cancel out one of the x's. So in doing this step, all I've done is this inch cancels one of the 2 inches down here. And I'm left with a denominator of inches times centimeters, which is an area unit, but it's mixed units. We want centimeters, centimeters, or inches, inches. So I'm going to do this step one more time. 1 inch is equal to 2.54 centimeters, and now this inch cancels the other one, and I'm left with centimeters times centimeters, or centimeters squared. But we want meters squared. So I need to convert each of these centimeters to meters. So I'm going to finish my fence post. I want to get rid of centimeters, and I want to go to meters. Now, I can do this twice, or I can recognize that really what I'm doing is I'm doing centimeters times centimeters, or centimeters squared, and meters times meters, which is meters squared. This is a shortcut for using squared units. And the conversion factor, there are 100 centimeters per 1 meter. And so I take the conversion and I square it because I'm doing it twice. If you notice, if I did that step prior to it, when I converted from inches to centimeters, I could have done 1 squared inches squared equal to 2.54 squared centimeters squared. Instead of doing the step twice, I can group it into one step. And so now, if you notice, these 2 centimeters in the denominator cancel with these 2 centimeters in the numerator, and I'm left with meters squared in the denominator. So if I look through all my units, everything's canceled except a newton in the numerator and a meter squared in the denominator, which is the units I want at the end. And so I have the right units, and so now it's just about pulling out my calculator, and I'm going to type in, I'm going to do 14.7, and I'm just going to multiply across in the numerator, times 1 times 1 times 1 times 100 squared, and that's my numerator. And then I'm going to divide by this entire denominator. I can do it down here. I'm going to put it in parentheses and make sure it groups it. 0.225 times 2.54 times 2.54, which is the same as 2.54 squared. Close the parentheses, so the whole denominator is now in there. When I hit enter, I get a value of 101,267. 101,267. And the units, again, are now a newton per meter squared, which is the same as a Pascal, a PA. Hope this helps. Let's move on to the next one. We got 2 more. Just a really simple one. In this case, we're going to assume that we have a y-axis and an x-axis. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And so I'm going to count out the slope. Here's a point right here. Here's a point. I'm looking where it matches to a whole number. I go down 2, and I go over 6. So my slope is -2 over +6. Down is negative, right is positive, which is the same as -1/3. And my intercept is at the point 0, 3. So my y-intercept is +3. So my slope-intercept form would be y equals -1/3 x plus 3. Now, where this applies to physics is we may not actually have y and x. We might be relating velocity v as it changes with respect to time. So all that really changes, instead of using a variable of y, which is an arbitrary variable for math, we're going to replace that with v, and x becomes a variable time. And when we measure the slope, that would be the change in its velocity, which is actually the acceleration. We might not use negative 1/3 to describe an acceleration. I might actually use a decimal value, 0.33, and it's still negative, plus 3. So that might be the equation if I was dealing with velocity versus time, as a change in velocity. Hope this helps. Last question. Here we go, another algebra problem. I'm given a value for y with this algebra problem. I'm trying to solve for x. So I'm going to plug in what I plug in for y. 6.75 equals 4.25 minus the square root of x over 9.8. And I'm trying to solve for x. Order of operations is important. Anytime we're solving for a variable, especially with a radical, we want to get the radical by itself. So I'm going to get the radical by itself by subtracting 4.25 from each side. Again, whatever we do to one side, we have to do to the other, basic algebra rules. And we're left with 2.5 on the left. And on the right side, I have negative square root of x over 9.8. Now, I can divide by -1 to get rid of the negative sign. It really doesn't matter. It's going to go away anyways. So I can cancel that out and make this negative. All right, because at this point, I'm now going to take the square root of both, or I'm going to square both sides to remove the radical. So I can take this whole thing and square it, which means I have to square that. Now you see when I square that whole thing, that negative goes away anyways. If I take 2.5 squared, I get 6.25 now on the left side, equal to x divided by 9.8. And to solve for x, I'm going to multiply both sides by 9.8. That cancels that. And I get a value, when I multiply times 9.8, of 61.25. Hopefully this is a good algebra refresher with solving for a variable, in this case one that's under the radical. And we'll see more problems like this as we move forward. Thank you very much. Best of luck to you. See if I can close out the video.